All right, so we're going to jump into a little bit of 8.5. And in 8.5, what we're going to talk about is graphing in what's called intercept form. Okay, and so we've talked a lot about standard form and we've talked about vertex form last week. Well, intercept form is just another form of quadratic. And as you can tell from the name, it's going to give us the intercepts. So just for your guys' notes, the general form of intercept form is going to look something like this: y equals a. And then you're going to see this two sets of parentheses, x minus p and x minus q. Kind of reminds you of when you would factor or FOIL. And so that's going to be our general form, where the values of p and q are your x-intercepts, again, where it hits the x-axis. So we're going to take a look at an example, but those are our x-intercepts. So let's say for a moment that y equals x minus 1 times the quantity x plus 3. Okay, so when we go to graph this, we know, all right, since this first set of parentheses, it's already in x minus p form for us. So that's nice. So we know that p must be 1. So we know that if we go to the point 1, 0, we're going to have an intercept. And then this x plus 3, you could decide to rewrite this as x minus negative 3. And that says the exact same thing as what we just had. But now it sort of looks like what we talked about with our x minus q form. So that means at negative 3, we must have another x-intercept somewhere over here at negative 3, 0. Okay, so we've already found two intercepts there. And so we've already found 2 points. And we know that a quadratic has to be symmetric. So if we were to draw on our axis of symmetry, well, it's got to be halfway between these 2 points. So it's actually going to be right here. All right. And this would be halfway in between negative 3 and positive 1 would be negative 1. The line x equals negative 1 would be your axis of symmetry. So to find the vertex, we could actually just plug this negative 1 in. If I plug in negative 1 into our equation, I'd have negative 1 minus 1 times negative 1 plus 3. Well, negative 1 minus 1 is negative 2, and negative 1 plus 3 is a positive 2. And so we would know, oh, all right, when we plug in negative 1, we get out negative 4. So we'd have to come down here 4. All right. So our vertex, we talked a lot about finding the vertex last week, would be negative 1, negative 4. And we also found 2 other points. And then you would just have to find 2 other points to get your 5 total points that you need to have graphed. Again, how did we know our intercepts? Well, we looked at our equation. If it was in x minus form right here, like it was right here, then we knew that p had to equal 1. So we had an intercept at 1, 0. And then we just rewrote this x plus 3 as x minus negative 3. And so we knew that the negative 3, since it was an x minus form, the negative 3 had to be your other x-intercept. Okay. Well, let's try one more example here for a minute. This time, let's say our equation is y equals, we'll throw a negative in front just for the fun of it, x plus 1 quantity times x minus 5. Now, if you didn't remember what to do, you could FOIL this, and you would have it in standard form, and then use our negative b over 2a, which we've talked about. But let's try graphing this in intercept form. So we have right here, we have our y-axis. And over here we have our x. And so I'm actually going to start with this second set of parentheses since it's already in x minus form for us. And so since it's in x minus q form, x minus q, I know that q must be 5. So if I go over 1, 2, 3, 4, 5, we must have an intercept here. A little bit of intuition, if I plugged in x equals 5 into my equation, if I plugged that in wherever I saw x, if I plugged in a 5 here and a 5 here, this second set of parentheses would end up being 0. the second set of parentheses here. And so that would end up being 0 times anything is just 0. So that's why we can do that. With the second set of parentheses, it's not in x minus form, but if we wrote it as x minus -1, it says the exact same thing. So we must have an intercept over here at -1. So that's how we found our x-intercepts. To find the vertex, we could either say, hey, the vertex, the x value must be halfway in between the -1, our -1, and our 5. And so you could do the math. And what you're really doing in your head is you're adding up -1 plus 5. You're taking the average of the two numbers. So you're adding up the two numbers, and then you're dividing by your number of terms. So -1 plus 5 is 4 over 2. So our x-coordinate of our vertex, the x-coordinate of our vertex must be 2. Well, to figure out what the y-coordinate is, plug it in. So if we plug in 2 for x, we'd have 2 plus 1 times 2 minus 5. And we'd get a positive 3 and a negative 3. So 3 times -3 would be -9. Okay. Oh, I forgot our negative sign out in front. We did that. So we have a negative out in front. So -1 times positive 3 times -3. So this would end up being our positive 9. So if we came up here to 2 and we went 1, 2, 3, 4, 5, 6, 7, 8. I'll do it in a different color. We'd be up here at 9. All right, and that would be our vertex. So we know our quadratic is going to look something like this. Okay. And so maybe I decide to pick the point. Maybe I plug in 3 or I plug in 1 and I get another couple points. I get some points right here. And our quadratic, in this case, opens down. And that should make sense because this negative out in front means our quadratic is going to open down. Okay. Look for another video on Wednesday, and I look forward to seeing you guys in Zoom.